In this question, we have some water at 18 degrees and we have an electric heater that's supplying energy. So let's put the electric heater at the bottom, and we are supplying energy in the form of heat to this amount of water, and the energy is 30 kilojoules. So that's how much energy we are supplying, 30 times 10 to the power 3 joules. The initial temperature of the water here is 18 degrees. So that's our initial temperature. The final temperature is unknown. That's what we're being asked to calculate. Calculate the final temperature. And we know that the mass of the water is 200 grams. All right, so if we write this out, the mass is 200, and to convert that to kilograms, you multiply by 10 to the minus 3. Your initial temperature is 18 degrees Celsius, and the specific heat capacity of water is 4,200. Okay, so the relationship we have when there's no change of state is that the amount of heat supplied is the product of the mass times the specific heat capacity times the change in temperature. So we can rearrange that to find the change in temperature. So that's Q, the amount of heat that's being supplied, which is 30,000. Divided by 20, or 200, sorry, times 10 to the minus 3 times 4,200. So we can calculate that. The answer is 35.7. So delta T is in Kelvin, but we're okay to use Celsius. So the change in temperature is 35 degrees. The temperature has gone up by 35.7. So if it was 18, it would end up being 18 plus 35.7. So we can say delta T equals T2 minus T1. So T2 equals T1 plus delta T equals 18 plus 35.7. And 18 plus 35.7 is 53.7. And that would be your final answer. So even when the question asks for a final temperature, you can find that if you know the initial temperature, as long as you can use this expression when there's no change in state. And of course, this is all assuming that there's no loss of energy to the surroundings. In practice, unless the cup is insulated, there'll be a loss of energy. But if you can assume that there's no heat lost, then we're okay to use this equation.